Deep dive into sklearn. Features election. Select percentile. What is select percentile? Select percentile is a feature selection technique in scikit-learn that uses a statistical test to rank features based on their ability to discriminate between classes. It then selects a specified percentage of the top-ranked features, effectively removing features deemed less informative. This can be particularly useful for reducing dimensionality. Removing irrelevant features can significantly simplify models and potentially improve performance. Avoiding overfitting. High-dimensional datasets are prone to overfitting, and selecting a subset of informative features helps mitigate this risk, improving model interpretability with fewer features. Understanding the relationship between input and output becomes easier. How it works. 1. Score calculation. The select percentile class requires a scoring function, e.g. fclassif, for classification problems to assess the importance of each feature. This function calculates a score based on the feature's ability to distinguish between classes. 2. Feature ranking based on the scores. Features are ranked from most informative to least informative. 3. Percentile selection. The percentile parameter specifies the percentage of features to keep. The select percentile object selects the top-ranking features corresponding to that percentage. 4. Feature transformation. The transform method of select percentile returns the selected features as a new dataset with reduced dimensionality. Key parameters. Scorefink. The scoring function to use for feature ranking. Common options include fclassif for classification problems. This calculates the ANOVA F value. Mutual info. Classif estimates mutual information between features and the target variable. Chi2 for categorical features and target. Calculates the chi-squared statistic. Fregression for regression problems. Calculates the ANOVA F value. Mutual infogression estimates mutual information between features and the target variable for regression. Percentile. The percentage of features to select an integer between 0 and 100. Advantages. Simplicity. It's relatively easy to understand and implement. Efficiency. It's computationally efficient for large datasets. Flexibility. Can be used with various scoring functions to cater to different problem types. Disadvantages. Bias towards high variance features. The method might favor features with high variance, even if they are not truly informative. Limited interpretability. The scores don't always provide clear insight into the specific relationship between features and the target variable. Not suitable for highly correlated features. If features are highly correlated, the select percentile might select redundant features. Example usage. Python. From sklearn. Features election. Import select percentile. fclassif. From sklearn. Datasets. Import load iris. From sklearn. Model selection. Import train test split. Load the iris dataset. Iris load iris. X iris. Data. Y iris. Target. Split the data into training and testing sets. Xtrain. Xtest. Ytrain. Ytest. Train test split X. Y. Test size 0.25. Random state 42. Select top 50 of features using ANOVA F value. Selector. Select percentile. Scorefin. fclassif. Percentile 50. Fit the selector to the training data. Selector. Fit Xtrain. Ytrain. Transform the training and testing data. Xtrain. Selected selector. Transform Xtrain. Xtest. Selected selector. Transform Xtest. Now you can train a model using the selected features. Integration with pipelines. Select percentile can be conveniently integrated into scikit-learn pipelines to streamline feature selection and model training. Python. From sklearn. Pipeline import pipeline. From sklearn, linear model import logistic regression. Create a pipeline with feature selection and a classifier. Pipeline. Features election. Select percentile scoffin CF classif. Percentile 50. Classifier. Logistic regression. Fit the pipeline to the training data. Pipeline. Fit xtrain. Y-train. Make predictions on the test data. YPRED pipeline. Predict xtest. Evaluate the performance of the pipeline. Choosing the right percentile. The ideal percentile value depends on your specific dataset and the desired level of feature reduction. It's often beneficial to experiment with different values and assess the performance of the model on a validation set. Alternatives. While select percentile is a basic and commonly used approach, other techniques might be more suitable for certain scenarios. Univariate feature selection methods like select k-best or select FPR select a fixed number of features based on statistical tests. Recursive feature elimination RFE. This method recursively removes features based on their importance in a model. Embedded methods. These methods perform feature selection during the model training process, e.g. L1 regularization in linear models. Conclusion. Select percentile is a versatile tool for reducing dimensionality and improving model performance. By choosing the right scoring function and percentile, you can effectively remove irrelevant features and enhance your model's accuracy and interpretability. It's essential to experiment with different configurations and compare their performance to find the optimal setup for your specific dataset.